This video, I am going to show how these two functions are derived. So actually, this is the book of Introduction to Statistical Learning. I am currently studying this book and I'm already in the chapter 3, which is linear regression, and I'm curious how these two functions were derived. As mentioned here, these functions were derived using some calculus. So basically, we'll be using a partial derivative. Later, I'm going to show you how these equations are derived. Just a brief background, this is the graph, and these red dots are the samples. And this line is the linear equation. This is the line to estimate. For example, this is the actual value. Using this line equation, what is the predicted value? So we're going to project it here, and this is the predicted value. So as we all know, the formula for linear is y is equals to mx plus b, and x is the value of the input, and b is the y-intercept, and m is the slope. And this slope is equivalent to theta 1, and this is equivalent to theta 0, or y estimate of I is equals to theta 0 plus theta 1 xi. So this prediction, this estimate, will be substituted here in this value. Where is it? In here. This is the one. So as you can see, it is already substituted. The residual sum of square. So this is the one. So this function is actually this one. So we're going to find the value of theta 1 and theta 0 to minimize this error. So let's start by writing this equation. As you can see, I just took it from the book and replace it with our equation. So this is the summation. I forgot. I need to put the square, the difference between the original value and the predicted value, and square it. Then what's the total? This n is the samples, number of samples. Now this is your final function, theta 0, theta 1, and let's remove this value here. We just want to simplify this one. Minus theta 0 plus theta 1 xi squared. And we know this is our function. So using a derivative, a partial derivative, as we all know, the partial derivative, just a recap, for example, the function of x and y, this is your function, x squared, y squared. What's the partial derivative with respect to x? So function, this is function with respect to x. We know that we will find the partial derivative with respect to x, meaning this y, other variables will be treated as constant. So this will be treated as constant. What's the derivative of this one is y squared. What's the derivative of x squared is 2x. Because this y squared is constant, so we'll put it in front. So 2y squared x. What about partial derivative with respect to y? So same it goes. We'll make x as constant. So what's the derivative? It's x squared 2y 2x squared y. So we will do the same in our equation. So I'm going to delete first. So we'll be using a partial derivative and a derivative for chain rule. Why? Because this is a complex equation. So after we do the derivative, we need to do the derivative of this inside function. So let's go back. What's the derivative of this one? Let's treat this as x, big X function. So it would be 2x derivative of x, something like that. So let's delete this one. So this would be 2 yi minus b0 plus b1 x1, then the derivative of this inside one. So what's the derivative of that one? So let's have a separate function here. yi minus plus b1 x1. We will treat this as constant, this as constant. So what's the derivative of constant? Is 0. This one is our variable. For example, what's the derivative of x? It's 1. So what's the derivative of this one? It's 1. What's the derivative of this? This is a constant, so it's a 0. So the derivative is -1. We're going to plug in it here. Sorry, it should be here, -1. So let's delete this part. Let's simplify -2. So since it is a constant, we are going to put it outside. Okay, yi minus, so let's simplify also this one, minus b1 xi, sorry, it should be xi. So negative times positive, it's negative. So that's our equation. Now let's do the distribution property. Yi plus 2 summation of 0 plus summation of xi. So we're going to find this beta 0. So let's transpose it. So this is our equation where we transpose it. Sorry, this should be 2. Of course, we need to cancel all the 2. Minus xi. How are we going to interpret this? So just a recap for a summation. Any summation for I is equals to 1 to n for a constant is equals to nc. So this is our general formula for summation of constant, and we know that this is constant. So this would be n theta 0 is equals to summation of yi minus theta 1 xi. Divide by n, for this n is the number of samples, 0 yi over n minus theta 1 xi over n. Okay, what is this one? Sum of all the values of y divided by the numbers of samples. Okay, so this is actually the mean. You need to add all the values, right, for y, then divided by the number of n's. So this is the mean. So what is this? This is y. Okay, I'm going to make it bigger. Y mean. And how about this? This one we'll put outside since it's constant. How about this? It's also a mean for x. So x bar. So meaning theta 0 is this one. So let's see if it matches with our formula in the book. Okay, let's see the book. Yes. So this is the one. This is the mean. And b1 and x1. So we are correct, guys. This would be our equation 1. Now let's move on finding the theta 1. Find theta 1. So we will do the same, guys, the way we do in finding the theta 0. So in here, instead of finding the partial derivative of theta 0, we'll do the partial derivative of theta 1. So we will treat other variables as constant. So as you can see, I do the same. Do the chain rule. Do the derivative of this internal function. So this is the output, negative xi. Because this one will be treated as constant. This is constant. And this is also like 2x or 2z. So we will not be confused. So this is the one. This is your constant. Constant times constant variable. What's the derivative? It's the constant, right? So this is the one. So we are going to plug in it here, negative xi. So let's try to simplify. So this is the simplify. Now our next step is to substitute this function in here. So let's do the substitution. So guys, this is our equation. So basically you can just do the distribution. You just need to distribute these functions. So what I just did, do some groupings. For example, I group the y and y, then the mean and the x. So I just group it accordingly. So this is my final. As you can see, I just distribute the summation, and this is the final equation. But we need to find the value for theta 1. So what we're going to do is to transpose that one. So sorry, I made a mistake. This should be plus 2 because it will be distributed, right? So 2 summation, sorry, 2 theta 1 summation xi minus the mean is equals to xi yi minus the y mean. Then we will cancel this. So theta 1 is xi yi minus y all over xi, so I minus x. So actually this is our formula. So let's check. It's a bit different, so we just need to do some algebraic manipulation. So let's go back here. Let's multiply this by let's multiply this by the denominator, which is xi minus x bar over x bar. So we all know that this is equals to 1. So we're just xi minus x bar yi minus y bar all over xi. Then this is the squared, so xi minus squared. Let's see if it's the same. Yeah, seems the same. X minus x bar. So actually it's the same. We can cancel this. So our final function is xi x bar times yi minus y bar all over summation of xi minus x bar squared. So this is our theta 1. So guys, thank you for watching. I hope you learned something from this video.